Welcome to the another session. We'll be discussing in this session about the continuity and the differentiability. So, what is the continuity? Already we discussed what is the limit and everything. So, if a limit extending to a f of x, what is this one? This is called the limit value. Is equal to f of a, then the function is said to be continuous. So, limit value is equal to functional value. Okay, limit value is equal to functional value. We call it as the continuous function. So, whether a is there, so where a continuity function may misfire means where it is not a function not continuous is discontinuous. What is the chance of discontinuity? What is the chance of discontinuity? So here what happened? This is the functional value. This is the left limit. This is the right limit. Left limit is equal to right limit. We call it as limit exist. Okay. Now, this one should be equal. This one should be equal. For example, f of a minus is equal to f of a plus, but not equal to f of a. This is one case, or f of a not defined. F of a not defined. This case is missing point discontinuity. This is called removable discontinuity. Okay. Now, if f of a minus is finite and not equal to f of a plus, this is called jump discontinuity. For example, one of these one or both of them are tending to infinity. We call it as infinite discontinuity. Infinite discontinuity. Next one is f of a minus is equal to f of a. This is left continuous. F of a plus is equal to f of a. This is called right continuous. Now, if anyone is saying f of x is continuous in the continuity always discussed in the open interval A to B. So, at A only, at A, we need to talk about only right continuity, and at B, we need to talk about only left continuity. Okay. So, if you look at the earlier thing like f of a is here, f of a plus here, f of a minus here. So here equal to one case, not equal to one case. Here equal to one case, not equal one case. Here equal to one case, not equal to. So every vertex. So there are 8 possibilities. Among 8 possibilities, only one possibility continued. Remaining rest of A7 possibilities are discontinuous. So types of discontinuity we'll discuss. Removable discontinuity and jump discontinuity, missing point discontinuity, etc. And coming to the concept here, f of x is said to be continuous at x is equal to a in its domain. Limit extending to a is equal to f of a. Means right limit is equal to, this should be, left limit should be equal to functional value. Limit value, left limit is equal to right limit is equal to functional value. F of x and g of x polynomial. Why we are taking especially polynomial? Polynomials are always continuous function and also differentiable. So h of x is f of x by g of rational function is discontinuous, is said to be discontinuous if g of x is equal to 0. They are talking about signum of g of x. So what is the signum of g of x? What is signum of g of x? Okay. Signum of g of x is equal to 1 if g of x is greater than 0, 0 if g of x is equal to 0, minus 1 g of x is less than 0. So wherever g of x is equal to 0, this function means g of a is equal to 0. The function is said to be discontinuous. And also, for example, x to the power of 2n, limit n tending to infinity we have taken. We are only x power n, I am taking this one. So what will happen, no? Anything between 0, 1, minus 1, etc. So here what happened? X is less than, lying between 0 and 1, this value going to be 0. And in rest of the cases, okay, exactly at x is equal to 1 or minus 1, plus 1 will be there, plus 1. And x is greater than 1, value goes to infinity. So f of x is equal to alpha of x if x is rational, beta of x if x is irrational. Is discontinuous all points except where alpha x is equal to beta x. Because as x tending to any value between every rational value, between two rational values, there are infinite many irrational. Between two irrational, there are many rational values are there. So where this is both are equal, so x tending to alpha or some p. What happens? If x p is rational, this is equal to alpha of p. But immediately you'll get irrational numbers, so beta of p. So it should be equal. So alpha x, beta x will be continuous only where alpha of x is equal to beta of x, and rest of the points it is discontinuous. F of x, g of x are continuous. F of g of x is continuous. And if f of g of x is continuous at x is equal to a, that means g of x is continuous of a, and so vice versa is possible. So f of g of x continuous. That means f of x is continuous and g of x is also continuous. F of x by g of x is continuous provided g of x should not be equal to 0. Where g of x is goes to 0, this is discontinuous. One function is continuous, one function is discontinuous, one function is continuous and one function is discontinuous, then sum will be equal to, sum will be discontinuous. Not only sum, even difference also discontinuous. But product may or may not be discontinuous. So it's not necessary that product of a continuous and discontinuous is a discontinuous. Need not be true. Sum of two continuous functions always continuous. Okay. So here next point, what is it? F of x, g of x are discontinuous at same point. Then their sum or product of the function may be continuous. Two discontinuous or sum of two discontinuous function may be continuous. May be continuous. It's not guaranteed, but may be continuous. Every polynomial function is continuous every point of the real line. Real line means real number system. An entire real number system, every polynomial function is continuous. And the very important logarithmic, exponential, trigonometric, inverse circle means inverse trigonometric, modulus are continuous in this domain. So you may ask, sir, how tan x is continuous? Actually, tan x is not defined at odd multiples of pi by 2. So wherever it is defined, it is continuous. At this point, it is not defined, so you need not worry. So that's why we mention are continuous in their domains. In their domains. Now, here in this slide, they are talking about a function f of x said to be said to have removable discontinuity. Removable discontinuity means left limit is equal to right limit. Limit exists, not equal to function value. So how we remove? We redefine this function. We redefine. So that is called removable discontinuity. Now next, missing point discontinuity. Missing point discontinuity means limit extending to a f of x exists finitely and f of a is not defined. For example, f of x is equal to x square minus 4 by x minus 2. X is not equal to. So clearly what happened here? Limit extending to 2, f of 2 is f of x is equal to 4. But function value is not defined. So I need to write here 4 if x is equal to 2. So this part is missing. So that's why missing point discontinuity. Or if I say f of x is equal to x square minus 4 by x minus 2, where x is not equal to is equal to 1 equal to 2. So what happened here? F of 2 is equal to 1. Limit extending to limit extending to 2, f of x is equal to 4. So what happened? Limit value not equal to functional value. So I need to redefine. So this is called the removable discontinuity. Isolated. So this is isolated. What happened here? Left side value, if I take the same function, you draw the graph, you have this one and here this one. So, but function value is somewhere. So, it is isolated from the neighborhood. So, this is the isolated and removable. In the removable, there are the two things. One is missing point. One is the isolated point of discontinuity. Second kind are irremovable, where you cannot remove. Means if you have the continuity like this, for example, this point is missed out or somewhere is defined, we can redefine. But irremovable discontinuity function left limit is here, right limit starts from here. Can we do any adjustment here? No. So this is called jump discontinuity or irremovable discontinuity. Next one is infinite discontinuity, means either left limit or right limit are both going to infinity or both are going to infinity, we call it as infinite discontinuity. Now, for example, a graph is there oscillating this one, but we are not sure where it is going, like sine of 1 by x as extending to 0. Where it is going, we are not sure. So that is the oscillating discontinuity. Now, once the limit's over, we move to the next part that is called the derivative. So, now there is a curve y is equal to f of x, right? This is x is equal to a. Now, this is a plus h. So, what is this change? Change in y by change in x. F dash of a is equal to limit h tending to 0 f of a plus h minus f of a by a plus h minus a. Or this is generalizing f dash of x is equal to limit h tending to 0 f of x minus f of x plus h minus f of x by, and this f dash of a we can say limit extending to a f of x minus f of a by x minus a. These are called first principle of derivatives. First principle of derivative. So what is exactly the derivative? Means delta y by delta x as change in x is small, which is equal to f dash of x. So again, limit extending to f of x minus f of a by x minus a. This has to be finite. Then only the function is said to be differentiable. Okay, and this is denominator goes to 0, so numerator has to be 0. So limit extending to a, f of x must be equal to f of a. So this is what happened. Function should be continuous. To check a function is differentiable, first of all we need to check whether it is different continuous or not. That's very very important. Now, if left derivative comes, that is called a left-hand derivative and right derivative. Okay, so left derivative is equal to right derivative is finite value. Then only we call it as the derivative of the function. So your sin x, derivative of sin x, derivative of cos x, everything has derived from this particular thing only. Now, graphically, how can we check whether the function is differentiable or not? For example, you have a curve with free hand like this. This is continuous everywhere and differentiable everywhere. You have a function like this. Look at here. Here it is not continuous. Here smooth and only. Here it is, sorry, here it is not differentiable, here not differentiable. Here not continuous. So as long as smooth curve is going graphically, that is differentiable. Wherever edge coming, not differentiable. And if the break comes, it is discontinuous. If the function is discontinuous, we call it as it is function is not differentiable also. So in under which scenario we call a function is not differentiable? A function f of x is said to be non-differentiable at x is equal to a if it is discontinuous. Even though f of x is continuous at x is equal to a, both left and right derivatives does not exist. Both exist finitely, but not equal. Means f dash of a minus is not equal to f dash of a plus. Or function though it is continuous, either or both left and right derivatives are infinite or does not exist. So this is not required, beta. This is not required. Why? Either one of them or both of them either exist or infinite, then the function is not differentiable. Function is not differentiable. But there is a special case. For example, if you are getting a curve like this, here derivative is nothing but a slope of the tangent. Okay. Here dy by dx is not possible, but this is differentiable only. So let us look at few questions on this one. Okay. So the first question is if f of x is equal to this, continuous everywhere, then a square plus b square. Continuous everywhere. So here 1 plus cos x, a minus x. So critical points where the function nature is changing is at x is equal to 0 we need to check, at x is equal to we need to check. So f of 0 minus as extending to means instead of writing everything I'm writing f of 0 minus what is this value? 1 plus cos 0 value will be equal to 2. And f of 0 plus x is greater than 0. I need to take this one. What is this value? A. Next, at x is equal to f of 2 minus is equal to a minus 2 and f of 2 plus is equal to 4 minus b square. So clearly a is equal to 2 and here a minus 2. What is a minus 2? 0 is equal to 4 minus b square. So b is equal to 4. Sorry, b square is equal to 4. A is equal to. So a square plus b square is equal to 8 is the answer. If f of x is continuous, okay, then so limit extending to 1 f of x is equal to k. So limit extending to 1, when you substitute here 9 minus 1, 8, this value 0, 0. So what I'll do is 9x minus 1 into root x minus 1 whole divided by this value I can write it as 3x plus 5 into x minus 1. So 3x square plus 5x minus 3x, etc. So when you cancel x minus 1, root or x minus 1 with this, you will be getting root x plus 1. Now this is the term, because of this you are getting 0 by 0. Substitute x is equal to 1. 9 minus 1, 8 by 3 plus 5, 8 into 2. So the answer is equal to 1 by 2. If a function defined as f of x is equal to this is continuous at x is equal to 0, what is a plus b? So here I need to check f of a minus, sorry, f of 0 minus is equal to f of 0 is equal to f of 0 plus. So limit extending to 0 a into 1 minus cos 2x, I can write it as 2 sin square x by x square is equal to b is equal to limit extending to 0 or root x by square root of 4 plus root x minus 2. So here this value is equal to 1. So clearly I got it as 2a is equal to b is equal to limit extending to 0 root x into, rationalize this, root over 4 plus root x plus 2, a plus b into a minus b. So 4 plus root x, okay, 4 plus root x minus 4. First 4 cancel, root x cancel. This value is equal to 2 plus 2, 4. So b is equal to 4 and a is equal to 2. The answer is equal to 6. So the next question is, if a function is given by this, they are talking about this function is continuous, then the value of a plus b. So clearly you need to find out left side function is one thing, right side one function, function value is b. So you have to find the limits. So limit extending to 0, 1 minus cos 2x by x square. What is this one? This is limit extending to 0. 1 minus cos 2x is 2 sin square x by x square. So this value is 1. So left hand limit is 2a. Left hand limit is equal to 2a. Now I need to find limit extending to 0 root x by square root of 4 plus root x minus 2. So let us rationalize this. Is equal to limit extending to 0 root x into square root of 4 plus root x plus 2 by a plus b into a minus b, 4 plus root x minus 4. So this cancel. In the next step, this one is also cancelled. So when x is equal to 0, this value is equal to 4. So clearly 2a is equal to b is equal to 4. So a plus b is equal to 6 is the answer. Next question is the value that should be assigned to f of 0. so that the function f of x is equal continuous at x is equal to 0. So here clearly f of 0 is equal to limit extending to 0 1 plus cos, 1 plus x, 1 plus x power cot x. So it is 1 to the power of infinity. So you can write e to the power of limit extending to 0, 1 plus x minus x. So you will get x into cot x. I can write by tan x. So the answer is equals to e because limit extending to 0, x by tan x is equal to 1. Next question is f of x is this when x is less than pi by 2 alpha continuous at. So very similar to the earlier questions only. So here left limit you need to find, right limit you need to find. Accordingly, these values we need to check it out. Okay. So extending to pi by 2 is there. So here what is this one? Limit extending to pi by 2, 1 minus, I am taking this value. Actually, you can write 1 minus cos x into, 1 minus sin x into everything you can write. Or let me write L hospital. Minus 3 sin square x into derivative of sin x is plus cos x divided by 3 cos square x is 6 cos x into minus sin x. So sin x, this one cancel with minus sign cancel, cos x is cancelled. So this value is equal to 1 by 2. This is pi by 2 minus. Limit extending to pi by 2, this value beta into 1 minus sin x derivative is minus cos x by, okay, this is 2 times of pi minus 2x into minus 2. So minus minus cancel, it is equal to beta by 2 to the 4 and let me take one more 2 here, 8. So it will be limit extending to pi by 2. Cos x can be written as sine of pi by 2 minus x by, this is pi by 2 minus x. So this value goes to 1. So 1 by 2 is equal to alpha is equal to beta by 8. So alpha is equal to 1 by 2, beta is equal to 4. So the answer is going to be, total will be equal to 2. Okay. The function f of x is defined below is continuous on the interval 0 to 8. And what is this f of x? So this function is continuous. So at 2, directly look at 2, the value going to 2. This is 4 plus 2a plus b. And what about this one? Left side I'm writing. So it is equal to 6 plus 2, 8. So 2a plus b is equal to 4. Now at 4, let us check it out. At 4, this is 12 plus 2, that is equal to 14 at 4. And at 4, this is 8a plus 5b. So multiply this one with 4 times. 16 is equal to 4a, 8a plus 4b. Let us subtract one from other. So minus 2 is equal to b. So b is equal to minus 2. A is equal to 3. Okay. So simply you need to write f of 2 minus is equal to f of 2 and f of 4 minus is equal to f of 4 plus. See, here already f of 2 is already included, so there is no problem. And f of 4, my plus also, my f of 4 also there. So you can check it out this one. Because it is taking care of f of 4 and this is taking care of f of 2. F of x is equal to so and so. Find the value of k, which the condition. So they are asking us to find limit extending to 0. K is equal to limit extending to 0, this value. What is this one? This is 9 power x minus 1 into 8 power x minus 1 by root 2. So I am writing this one, rationalization directly. 2 minus of 1 plus cos x, under root of this one and the root of this one. I am rationalizing this. So denominator will come 2 minus 1 minus cos x. So it is equal to limit extending to 0, 9 power x minus 1 into 8 power x minus 1. And actually, you take this x is equal to 0, root 2 plus root 2. This is 2 root 2. I need not wait for that. And here 1 minus cos x. So what I'll do is, I'll divide with x square and here divide with x square. So this portion is log 9 and this is log 8 and this value is 1 by 2 into 2 root 2. Okay. So here what happened? Log 9. This 2 will come here. So this is 4 root 2 into a power x. So limit extending to 0, a power x minus 1 by x is equal to log a. So this is 4 root 2 into log 9 log 8. So this can be written as 3 log, sorry, 2 log 3 and this is 2 log 3 log 2. So into 6 log 3 log 2. Okay. So 24 root 2 into this one. So here options are not there. I think this should be for value of k for which the function is continuous. So it should be like k into log uh, 3 into log 2 should be there. Okay. So if I want only this one, uh, this is not properly framed. They should have mentioned this one as, okay, f of x is equal to so and so where x is not equal to 0 is equal to k log 3 log 2 x is equal to 0, then the answer is going to be this. Okay. The values of x for which this function is fails to be continuous. Polynomial. So less than 1, there is no chance. Greater than 2, no chance. Only you need to check at x is equal to 1 and at x is equal to 2. So you may have the possibility either 1 or 2 or 0 point. At x is equal to 1, left side value is 0. Right side value also 0. No problem. So f of 1 minus is equal to f of 1 plus. Whereas f of 2 minus is equal to 0 and f of 2 plus is equal to 1. So it is discontinuous at one point. Okay, it's not 2. Okay, the values of x, yes, at x is equal to 2, discontinuous. Number of points are 1 point, but at x is equal to 2. At x is equal to 2, this is discontinuous. Okay, number of the values of x they are asking. So answer should be 2. F of x is equal to 1 minus log kx by 1 minus cos kx by x sin x. X is not equal to 0. 1 by 2 x is equal to 0. Continuous at x is equal to 0. The value of k is. So 1 by 2 is equal to limit extending to 0. 1 minus cos kx by x into sin x. So what I'll do, I'll put a x here, I'll write here x here. So this value is 1. So if I write here k square and I'll multiply here k square. In that case, 1 by 2 is equal to, this value is 1 by 2, this value is 1. So k square by 2. So k is equal to plus or minus 1. Because this is the standard formula, this one also standard formula. K is equal to limit extending to 0 log x by x minus 1. So go for the L'Hospital rule. Limit extending to 0. Okay. Oh, limit extending to 1. Sorry. So 1 by x by 1. So is equal to 1. Limit value is equal to 1. Okay. Again, continuous at 2. So left limit is 4k, right limit is 3. K is equal to 3 by 4. F of x is equal to step x. The function is continuous at. See, step x graph is clearly, we'll talk about the step x always discontinuous at integral values. Discontinuous at integral values. So, this is not possible, this is not possible, this is not possible. Only continuous at 1.5. This is the function. The function is continuous. They're talking about the continuity only. So, look at here where the denominator, is there any chance of denominator going to be 0? Okay. And they're talking function is continuous for all real values of x. The function is continuous only for x greater than 1. Function is continuous at x is equal to 1, etc. So, look at here. This question is x square minus 1 by x square minus 2x minus 2. 2 times of x minus 1 minus 1. This is x greater than 1. So, what you are going to get? X square minus 1 by x square minus 2x. So x minus 1 whole square. So which is equal to x plus 1 by x minus 1, where x is greater than 1. Okay. Now x is less than 1. This question is x square minus 1 by x square plus 2 times of x minus 1 minus 1, which is x square minus 1 by x square plus 2x minus 3, which can be written as x square minus 1 by x plus 1 into x minus 1 into x minus 1 into x plus 3. So which is x plus 1 by x plus 3. So left side function is this one, right side function is this one. At x is equal to 1, at x is equal to 1, functional value is 1 by 2. Function is continuous for all x? No, because at x is equal to 1, this value is 1 by 2, but 1 plus the value function is not defined, going to some infinity. Function is continuous only for x greater than 1. Function is continuous, this one is also wrong. So the function is not continuous at x is equal to 1. So I'll take the answer as the D1. So this is not continuous at x is equal to 1. Sin x, f of x is sin x when x is rational. Look at it. F of x is equal to sin x. That question supposed to x is rational is equal to cos x, where x is irrational. So there are infinite irrational between two rational points. This will be continuous only if sin x is equal to cos x. So this is possible at x is equal to n pi plus pi by 4. Okay. Only when it is n pi plus pi by 4. No, actually you cannot say this one also because, right. Because tan x is equal to 1 should come. Tan x is equal to 1. So that answer is n pi plus pi by 4. So what happened? No, at either side of this one, whether you take sign rational or irrational, both are giving the value same. So that's why whenever rational irrational comes, continuous means you need to equate those terms. The function f of x is equals to x minus modulus of x into 1 minus x. So whether this continuous function is continuous in the interval minus 1, etc., things are there. So here, what happened? No, x into x minus 1, if I take modulus of this, is equal to x square minus x, if x is less than 0 or x is greater than 1, is equal to x minus x square, 0 less than x less than 1. So f of x is equal to x minus x square plus x if x is less than 0 is equal to x plus x square minus x. Okay. If 0 less than x less than 1, again, x minus x square plus x if x is greater than 1. So just look at 0. What is this value? This value is 0 and this value is also 0. At 0 continuous. Okay. At 1, what happened? This one cancel. Left limit is 1. Right limit is 2x minus 1 is 1. So this is going to be continuous in the closed interval minus 1 to plus 1. So there is no problem of that. So what is this question? F of x is equal to this one. So f of x is equal to x log of cos x by log of 1 plus x square. This is the thing. So extending to 0, what is the situation? This value goes to 0. Extending to 0, this value goes to 0. And extending to 0, this value is also going to 0. All the three things are going to be 0. But we have limit extending to 0, log of 1 plus x by x is equal to 1. So as per that one, so here you can write limit extending to 0. If I write x squared, so you will be getting log of cos x by x. So it is 0 by 0 form. Look at here. Limit extending to 0. This is minus tan x by 1, which is equal to 0 function value. So function is continuous. So this option is ruled out. Differentiable not continuous also ruled out. So only these two things are there. So let me check for the differentiability condition at x is equal to 0. So f dash of 0 is equal to f dash of 0 is equal to limit extending to 0, f of x is x log of cos x by log of 1 plus x square minus f of 0, 0 by x. So x cancel. So limit extending to 0, log of cos x by
log of 1 plus x square, which is equal to El Hospital rule. If I apply limit extending to 0 minus tan x by 2x into 1 plus x square, which value is equal minus 1 by 2 finite. So it is differentiable also. It is continuous as well as differentiable. If the function f of x is equal to so and so, then f of 0 is equal to. So what you write? F of x is equal to, you write e power x square minus 1 plus 1 minus cos x. So you write here x square, you write here x square. Okay. So this value is equal to 1 by 2. This value is equal to 1. Hence the answer is 3 by 2. Hence answer is 3 by 2. Next question is the value of f of 0 so that this function is continuous. So what is the limit value you need to write? See, whenever log of this value is there, so I will write it as log of 1 plus x by a by x. I need to write by x by a into a. I need to write. And yes, this is minus sign is there. I need that sign. Minus log of 1 minus x by b. Actually, x is there. I need minus x by b. So here plus b. So this value is equal to 1. This value is equal to 1. Okay. So you are going to get the value as b plus a by ab. So this value is 1 by a and 1 by b is the answer. So all these questions require the basic formulas only. The discontinuous points of 1 by log of discontinuous points of 1 by log mod x. At 0 function not differentiable. Okay, log 0 and mod x is equal to, okay, what is the thing? You can try this way. This is the log mod x graph. When I take 1 by reciprocal of that, you will be taking this value. Okay, you are going to get like this and it will be like this. And similarly, you are going to get like this. So at the 0 and these points, because here mod x. So first of all, at x is equal to 0, function is not defined. Log x only not defined. Okay. Next one is log mod x is equal to 0, where mod x is equal to 1. So the answer is 0 and plus or minus 1. Step x denote the greatest integer function not exceeding x if the function f of x is defined by this continuous. What is the a comma b? Okay, what is the a comma b? So this question is f of x is this one continuous. So limit extending to 0 minus a plus 2 cos x by x square. So this should be finite value. So denominator is 0. So numerator has to be 0. So a is equal to minus 2. And limit extending to 0 plus b tan of a by step of x plus 4 as extending to 0 plus this value is equal to 4. So b is equal to, here my a is equal to minus 2 if I write. So b tan of minus 1 by 2. B tan of minus 1 by 2. Okay, this is the value you are supposed to write. But here what happened? You need to check it out. What is this limit value? What is this limit value now? So this is equal to, when a is equal minus 2, take minus 2 out. So 1 minus cos x by x square. So this value is equal, you know that 1 by 2. So left limit is minus 1 and a is equal to minus 2. So minus 1 is equal to b tan of minus 1 by 2. Actually, it is leading to nowhere. So here, maybe what should be done? Okay. So there is a some typo error. Let me check it out. What is the answer? A is equal minus 2 is there. And what is the b value? Is equal minus 1 means this value should goes to 1. Okay. So here something is missing in this particular question. Okay. Here something is missing in this particular question. Okay. So as per the data, you take till here. Okay. Right. Next question is f is defined from R2. Function f is defined from R2 or this one. F is a continuous on the set. Okay. So you need to look at the minus 2, minus 1. So this value is x plus 2 by, I can write it as x plus 1 into x plus 2. This is f of x. So is equal to, I can write it as 1 by x plus 1, where x is not equal to minus 2. So f of minus 2 is equal to minus 1. And f of minus 2 is equal to minus 1 is given. And f of minus 1 is equal to 1 by this one. It is undefined. So the function is continuous in r minus of minus 1 interval. Left continuous. So the function is left continuous means limit extending to 0 minus. So p plus q to the power of 1 by x by r plus s to the power of 1 by x. Q is greater than 0, q to the power of 1 by x goes to 0. So this value will be, both will be goes to 0, 1. So you will be getting p is equal to r as the answer. So here they are talking about a is equal to limit extending to pi by 4, 1 minus root 2 cos sin x by pi minus 4x. Apply El Hospital rule. Minus root 2 into cos x is 1 by root 2 by minus 4 is equal to 1 by 4 is 0.25. So x greater than 0. Step x is 0. So this entire thing is 0 by something. So value will be equal to 0. So a is equal to 2. Look at here. Limit extending to 0 plus sine of step x by x. So this is going to 0, but already this is 0. So the value will be equal to 0. A is equal to. So 2 is equal to beta plus limit extending to 0 step of sin x minus, okay, sin x minus x by x cube. Your step is there, sin x minus x by. So here one thing is sin x is less than x. Sin x minus x, okay. You can write sin x is greater than x minus x cube by 3 factorial, etc. But let us look at here. So you will be getting here already you are getting a is equal to 2 as this value goes to be 0. Now sin x minus x is equal to minus x cube by 3 factorial plus x power 5 by 5 factorial, etc. So sin x minus x by x cube is equal to minus 1 by 6 plus x square by 5 factorial, etc. So when you are applying step, so limit extending to 0, this value will be this one. And when you are applying step, this value will be equal to minus 1. Okay. So beta minus 1 is equal to 2. Alpha is equal to 2. So beta minus 1 is equal to 1 is the answer. So with this one, I'm concluding the session. Thank you very much. Particularly in this chapter, you need to concentrate on limit extending to a f of x is equal to f of a. And limit extending to a f of x minus f of a by x minus a is f dash of a.